Welcome to Maths for You channel. Another past question on mathematical induction. Prove by induction that for n is an element of positive integer, fn, function of n, equal 5 to the power of n plus 8n plus 3 is divisible by 4. We'll have to prove the fn is divisible by 4 for all the positive integer values. Let me write that function again. Fn equal 5 to the power of n plus 8n plus 3. As normal, start from step 1. Step 1 is for n equal 1. F1, n equal 1, F1 equal 5 to the power of 1, n equal 1, plus 8 times 1 plus 3. So that will be 5 plus 8 plus 3 is 16. 16 is divisible by 4. 4 times 4. So F1 divisible by 4. For n equal 1 is done. Step 2, for n equal k. K is a positive integer, an arbitrary positive integer. Assume Fk is divisible by 4. Fk equal 5 to the power k plus 8k plus 3 is divisible by 4. So we assume the function 5 to the power k plus 8k plus 3 is divisible by 4. Step 3, for n plus 1, unlike the other proof of induction, which we add value certain function to left hand side and then prove the other side to the right hand side is true for k plus 1. Here what we need to prove it's for k plus 1 is divisible by the function divisible by 4. So right, n equal k plus 1, fk1, if you could substitute that k plus 1 for n, 5 to the power k plus 1 plus 8 times k plus 1 plus 3. 5 to the power k plus 1 can be written as 5 to the power k times 5 to the power 1 plus 8k. If you could expand the bracket, remove the bracket, 8k plus 8 plus 3. So the 5 to the power 1 is 5, so 5 times 5 to the power k plus 8k plus 11. But we have 5 times 5 to the power of k. We assume that 5 to the power of k plus 8k and 3 is divisible by 4. So we need to get that function. But the 5 to the power of k is multiplied by 5. So try and get other function in the order of getting the function 5 to the power k plus 8k plus 3. Right. So 5 times 5 to the k, instead of 8k, I just wrote it as 40k minus 8k. So that we can get 8k out of it. 40k minus 32k. So that means no change. 40k minus 32k is 8k. And then again, I wrote 11 as 15 minus 4. Again, 15 is a multiple of 5 and then 5 times 3. So 11 is 15 minus 4. Again, no change. So now we can separate that. So 5 times 5 to the power k plus 40k plus 15 and then again minus 32 minus 4. If you take 5 out of the bracket, out of that function, first three components, 5 to the power k plus 8k plus 3 inside the bracket 5 times and minus 4 out. Purposely, I just wanted to prove that 4 is divisible by 4, so I took 4 out. 4, 8k minus 1. Right, we could analyze it. The inside the bracket 5 to the power k plus 8k plus 3, we have assumed that will be divisible by 4. So that is this is divisible by 4. If that's the case, 5 times the function divisible by 4, of course. The rest of the function minus 4 times 8k minus 4. This is 4 multiple of 4. So therefore this function minus 4 times 8 plus minus 8k minus 1 divisible by 4. If that's so, or that fk k plus 1 function of k plus 1 divisible by 4. We have proved that. So therefore, fn equal 5 to the power n plus 8k plus 3 divisible by 4. Thank you. Please subscribe the channel and select auto notification. If anyone have a similar question on this topic, please put it in comment. Then I'll make a video on that particular question or your question. Thank you.